Okay, question number 8 says, take this picture here of Cyclops. I like this one. I used it for the Angle Coach Quest picture. And we're going to take this picture and we're going to move it 7 units to the left. Remember, horizontals first, and then down 4 units. Okay, so to do that, we need a vector to translate, right? So I'm just going to grab my vector tool. It's in the line toolbox. We got vector between points. Depending on what version you have, you might have just vector tool. Okay, so I'm going to grab that tool. When we make a vector, all we have to do is put a vector that has these components to it. So I'm going to take a point, and it doesn't matter where our vector is at all. I'm going to just put a starting point somewhere, and I'm going to draw my vector so that it moves 2, 3, 4, 5, 6, 7 units to the right. That's like the side of a triangle, right? And down 4, 1, 2, 3, 4. So there's a vector that moves 7 units to the left and down 4. Alright, so now that I have my vector, all I have to do is go in my transformation toolbox, grab my translate tool, and just say, alright, Geogebra, I want to translate this picture, so I'm going to click on it by this vector. And this is why it doesn't matter where the vector is at all. I can actually move A around. Oops, better not do that. Sorry, I can just move the vector around. It doesn't matter. This vector, by its size and its direction, tells us how all points are going to move. Doesn't matter where the vector is. This is what tells the points to move. Okay. Question number 9 is a Pythagorean inequality question. So we have a triangle that has these 3 side lengths in units: 4 units, 7 units, 9 units. So what kind of triangle will this make? Will it be acute, meaning all the angles are less than 90 degrees? Will it be a right triangle, so one of the angles is guaranteed to be a 90-degree perpendicular relationship, right? Or obtuse, meaning there's going to be an angle that's larger than 90 degrees. So let's check it out. If we do the algebra side of this here and set up our Pythagorean equation, but not say equal to, but check to see if a squared plus b squared equals c squared. 9 is our longest side, so this is just going to be reserved for c. Therefore, 4 and 7 are going to be our a and our b. So all we have to do is check to see if, say, 4 squared plus 7 squared, right? There's our a squared plus b squared. Does that equal, so I'm going to put a little question mark above the equal sign, does that equal our c squared, which would be 9 squared? So 4 squared, 4 times 4 is 16, plus 7 squared, which is 49. Okay, does that equal 9 squared, which is 81? Okay, I don't think it's going to. We could do 16 plus 40 is 56, and then 56 plus 9, I believe, is 65. Right, so that definitely doesn't equal each other, right? So we know now that this isn't going to be a right triangle because our a squared plus b squared didn't actually equal c squared. So then the question becomes, well, if it's not a right triangle, then it's going to be acute or obtuse. Which one is it? So let's construct, that's what this, let's construct this triangle in Geogebra to verify which one it's going to be. So in our line toolbox, we've been using this segment between 2 points tool. I want to show you this other segment tool with fixed length. Okay, so I'm going to grab this tool here. What we're going to do is we're going to click somewhere to put an endpoint down for our segment. So notice it put an endpoint here, and it's asking what length do we want. So I'm going to put 4, and I'm going to hit enter. So there's a segment of length 4. The cool thing about this tool is I can grab B and move it around, right? And notice that segment's going to keep that length 4, which means B just follows a circular path. So we can change the angle of the segment and guarantee that it'll always be 4. So that's pretty cool. that segment with fixed length tool. So I'm going to do that again. I'm going to click right below, and I'm going to make my next segment length be 7. And then click another one and make this one, say, 9. So there's my 3 lengths. Let's see what kind of triangle this is going to make. So I'm going to take this smaller segment, and then I'm going to take my next larger side, or angle, or side I mean, the 7, and this is a perpendicular side here, so this would be a right triangle if these would match up, and they don't. See that? So now, how can we figure out how can we figure out what kind of triangle this will be? Well, notice this point F, it's following a circular path, right? So I'm going to grab my circle tool, click on the endpoint down here to be the center, and draw a radius. Isn't this really what F is following, right? That radius here. So where does this segment then meet the circle? Hey, check it out. Right there. So this angle now is bigger than 90 degrees, so it makes an obtuse. Remember, when c squared is bigger than our a squared plus b squared, it actually makes that angle bigger than 90 degrees, right, for that longer segment. So it makes an obtuse triangle. Okay, and then last question, question number 10. A point translates with vector 4, -4. How far did it translate? Show an illustration of this translation and show the answer by making squares of the side lengths and argue with Pythagorean theorem and area. So I just wanted you to focus on area. A point translates with vector 4, -4. Okay, so let's draw the vector. Grab the vector tool, put a point somewhere. Okay, this point's going to go 4 units to the right, and then down 4. So there's our vector. So how far did it translate? Okay, so I'm going to grab my segment tool, and it went 4 to the right, and it went down 4. There's our perpendicular angle relationship. So now we can use Pythagorean's theorem. Let's use that regular polygon tool, because a square is just a regular polygon. So I'm going to grab that regular polygon tool. I'm going to click on A and then B, and we want 4 vertices to make a square. Oops, I made it the wrong direction. I'm going to undo, and I'm going to click B and then A, 4. And then I'm going to do the same thing here. Oop, wrong way. And this is going to make our squares, right? So these are the areas of our side length squared. Okay, so check this out too. In our measurement toolbox, we can actually measure area. I'm just going to click on these squares and see. Hey, there we go. This length of 4 here, squared is 16. This going down 4, -4 squared is 16. We add them up, so the area of a square formed by this side length is 32. Therefore, the side length automatically is going to be the square root of that area. So the square root of 32. So how far did it translate? The square root of 32 units, or about, that's an irrational number, right? But we can approximate square root of 32, about 5.66 units. So just over 5.5. 5.66. Alright guys, that's it for the review. Hope that made sense, and I hope you guys will do well on the test.